So what we're looking at here is related graphs, and we're already familiar with how different functions look on a graph. So for example, if it had an x squared, it would be like a U-shaped graph. If it was a cubed, it's a cubic graph, and so on. So we're going to look at some changes that happen in the equation of the function and how that impacts the graph that would be plotted, okay? So the first thing we're going to look at is f of x plus a. So you have your function here. I've just put in the function of x, which is a straight line, where y is equal to x. And you can see here that f of x plus a, where the a is outside of the bracket, this is only going to change the y value of the line. So what's going to happen is if I let a equal to 1, or even 2 in this case, what's happened is when x is 0, now the coordinate is 0, 2. And similarly, if I let a be minus 2, the y coordinate now is minus 2. So it's basically taken our parent function, our green line here, and pulled it down 2 places. So this type of change where the something is added or subtracted from the function is only going to change the y value because it's happening outside of the bracket. So it's not affecting the x value at all. Now, what about if we had a change inside of the bracket alongside the x? Well, then that's going to change the x coordinate. So again, if we had minus 2, what happens now is our parent function is still that green line, but actually our graph has been shifted over 2 places. So if you had x was 0 and you are subtracting 2, well then you're going to have to add 2 to get back to the point where y is 0. So you can see that your graph has moved over to the right 2 places. Now, what about if I make that a positive 2? You can see that my graph has been pulled to the left 2 places. Okay, now how does this impact on, say, a quadratic graph? So we're used to looking at quadratic graphs. You know your quadratic graph is x squared. That's your green parent function there. It's symmetrical about the y-axis and it sits on the point 0, 0. So its minimum turning point is 0, 0. Notice that, again, we have a as positive 2. So our function is x plus 2 to be squared. And basically all that has happened is that your graph has been pulled back 2 places. So it's been moved to the left 2 places. And if I make a negative 2, you'll see that our graph has been shifted to the right 2 places, or minus 4 as it is here, it's been shifted 4 places to the right. Okay, so it might be the opposite to what you would have expected. By going for minus, you're actually pushing it to the positive, and by going for positive, you're pushing it to the negative. Okay, so let's have a look now at what about if I multiply my graph by something? Well, that's going to have the effect of stretching your graph, okay? Now, in this case, we have a negative value. And just beware that if you have a negative value, then you are going to have a reflection through the x-axis. But what about if that was positive? It's going to have a stretching effect or a contracting effect on your graph, okay? So again, I'm going to give you the link for this and you're going to play around with this and see how the graphs change, okay? And then what about, again, if there is a change, but in this instance, we're multiplying the x part and not just the y coordinate. Then in this instance, again, you're going to have a contraction there or the same contraction and expansion. So you're going to play around with that and see what happens, okay? Always comparing it to the parent function.